Day 20 Notes, Advanced Algebra 2. Today we're going to continue looking for patterns when we multiply binomials and we find their quadratic results. First off, let's review a couple things from yesterday, Day 19. In Day 19 we practiced squaring a binomial, and the result of a squared binomial is what we found to be called a perfect square trinomial. So let's remind ourselves of what that might look like. If I square a binomial, let's say I give you one that looks like x plus 2 squared. When multiplied together, don't forget that this should be written twice and then FOILed, but when multiplied together we receive a result that looks like x squared plus 4x plus 4. And the reason for that is we square the first term, square the last term to get our first and last term of our trinomial. And this middle term here came from 2 times the product of our first and second term of our original binomial. So this is a shortcut that we've practiced, and you should recognize at this point, if we're asked to square the binomial, we end up with a perfect square trinomial of this form. Let's quickly look at another. If I were to give you something like 2x plus 7 squared, its result must be first part A squared, so 2x squared is 4x squared. The last value is going to be 7 squared, which is a positive 49. Since we have an addition problem, we're going to reuse that addition sign, and we need to find what 2 times A times B is. A being this first piece, B being the second. 2 times 2x times 7 is equal to 4 times 7, which is 28, and the x has to remain, so 28x. This is the perfect square trinomial that comes from the original binomial squared here. Again, this was just a real quick review from yesterday's notes. If this doesn't look familiar to you, go back to our notes, go back to our classroom activity from yesterday, and review those practice problems. Today we're going to look at something that's called binomial conjugates. And that's just a mathematical term that we use to recognize this pattern here. Let's say that I start with example 1 with two binomials. One of them is x plus 5 and the other is x minus 5. These are both binomials because they have two terms, and they're known as conjugates because the signs in between those two terms are opposites of one another. So again, x plus 5 and x minus 5 are known in mathematics as conjugates. Let's go ahead and FOIL this and see what sort of result we get. For our first product, we have to multiply x times x. That makes x squared. For our outside products, that's x times 5, which is negative 5, so we're going to write a negative 5x here. For our inside products, we have a positive 5 and a positive x. That multiplies together to make a 5x. And for our last products, we have a positive 5 times a negative 5, which equals negative 25. After we combine the like terms, we're left with x squared minus 25, because these two like terms cancel each other out because their sum is 0. Negative 5x plus 5x is 0. So we're left with a new binomial that looks like this. Here's another example. Let's go with 3x minus 8 and its conjugate, which would be 3x plus 8. When we FOIL these two together, our first calculations, our first product, would be 3x times 3x, which gives us 9x squared. Then our outside product, which is 8 times 3x, that's a positive 24x. Then our inside products, negative 8 times 3x, which is a negative 24x. And for our last products, negative 8 times 8, which is a negative 64. The middle two terms again can combine, but you'll notice here too they will cancel because their sum is 0. We're left with 9x squared minus 64 as our result. Perhaps you're starting to see the pattern right now. We'll continue this discussion on the next video, and we'll follow through with your initial thoughts.